Hello everyone, class 12th topic is Ullmann reaction with mechanism. First, let's understand what is Ullmann reaction. Two molecules of haloarine. Now first must be clear what is X. It can be chlorine, it can be bromine, it can be iodine. Now two molecules of haloarenes are going to react with two atoms of copper. Two molecules of CuX will eliminate out and benzene rings will combine. Diphenyl will generate. That's all. Now first, in simple way, we can learn it because mechanism is not in the syllabus of 12th class. So we should have a technique to learn it directly. X connected to carbon. Between X and carbon, X is more electronegative. So the electrons are toward X. So that's why X is negative. Carbon is positive. Similarly here, X is negative. Carbon is positive. We know about copper. Copper mostly available in +1, +2 oxidation states. Means copper is a positive particle. So just attack positive on negative and combine them CuX, CuX. Two CuX particles will eliminate out and benzene rings you can combine to create diphenyl. This is a way to learn it, a trick to learn it you can say, but it is not an actual mechanism. Let's go for actual mechanism now. Mechanism. I have divided this mechanism in 4 steps so you can understand it very easily. First step. This is haloarine, first molecule of haloarine going to react with first atom of copper. First you need to understand copper outermost electronic configuration. It's 3d10 4s1. And we know 4p is also available, which is vacant. This is ground state electronic configuration of copper. Now in this reaction, what first copper is doing, copper is exciting its electron from 3d to 4p. So there will be 3 unpaired electrons in copper, 1, 2, 3. So those 3 unpaired electrons I am going to write here. And in this condition, copper have zero oxidation state because all electrons are with copper. No electron is lost or gained. So that's why the oxidation state of copper is 0 here. Now, in this step, what copper is doing? Copper is inserting itself between carbon and X. Means copper atom will fix itself between carbon and X. How? This electron of carbon will make covalent bond with this unpaired electron of copper. This unpaired electron of X will make covalent bond with this unpaired electron of copper, and copper will be fitted between X and carbon. So the compound generated will be this CuX. Please be careful in counting of electrons. 2 unpaired electrons of copper are used. These are 2 unpaired electrons are used by copper to make one covalent bond with carbon and second covalent bond with X, and third unpaired electron is as it is. Now oxidation state. Because we know X is more electronegative than copper, so electrons will be pulled toward X. Carbon is more electronegative than copper, so electrons will be pulled toward carbon, due to which copper is losing its 2 electron, so its charge will become partial +2. partially it is losing its electron. Now means its oxidation state is +2. In start oxidation state was 0, now it is +2. 0 to +2. If oxidation state is changing from 0 to +2, means what is happening? Oxidation is happened there. In 11th class, redox reaction chapter was there, where we learned if oxidation states are increasing, means oxidation is happening. Whose oxidation is happening? Copper oxidation is happening. So that's why we are calling this step oxidative addition, because it is added between carbon and X with its oxidation. So this is the first step of the mechanism. Now second, this is intermediate which we got. Oxidation state is +2. Now this intermediate reacts with another atom of copper. In balanced chemical equation we have watched 2 copper atoms are utilized. So here we have a role of second copper atom. We know because electrons are toward X, so X is carrying what charge? Partial negative charge. Second copper atom will lose 1 electron. Because we know copper can show +1 oxidation state, and in this oxidation state it is getting 3d10, stable electronic configuration. Now, due to this 1 electron, this copper have +2 charge, this is electron with negative charge. This negative electron will go toward positive particle and bond between copper and X will break. And obviously X will get both electrons, due to which X will become a negative particle. This negative X, -1 charge, now it have a complete -1 because it got 1 electron from copper completely toward itself. This -1, this +1, they will combine to create CuX. In balanced chemical equation, 2 CuX were generated. Out of 2, 1 is generated like this. Now what about this copper? Please be careful. After loss of, already it is in +2 oxidation state because both electrons are toward X and carbon. After this process, it will be in this condition. Check carefully. This condition. This unpaired electron as it is. This unpaired electron, from where we got it? This electron. This electron will come here as an unpaired electron, and this electron will go with X. So now copper oxidation state will be +1 because now only 1 electron is going toward carbon. Here 2 electrons were going toward, one was going toward X and one was going toward carbon. So +2 it was. Now X is eliminated and at the place of X, 1 electron it got. So its oxidation state will change from +2 to +1 and side product CuX will generate. Now please be careful. From +2 to +1 oxidation state is changed. +2 to +1. Decrease in oxidation state. Decrease in oxidation state means reduction. Increase in oxidation state means oxidation. Decrease in oxidation state means reduction. Means now in second step, what is happening? Reduction of this copper is happening. Third step. This is another intermediate which we got. What it will do? It will react with another haloarene particle. In balanced chemical equation, we have watched two haloarine particles were there. One we have utilized. Now second one. What it will do? It will do same insertion like in first step it has done. Here, it will fit itself. This copper will fit itself between carbon and X. How? 2 unpair electron it have. 1 unpair electron will make bond with this unpair electron of carbon. Second unpair electron will make bond with this unpair electron of X, due to which this compound you will get. Check carefully. This benzene ring I am writing star benzene ring. This is star benzene ring which was already connected with copper. This is new benzene ring which is inserted from new haloarine. 2 electrons will be there in every bond. Now please check oxidation state of this copper. X is more electronegative than copper. Electrons are going toward X. Carbon is more electronegative than copper. Carbon is more electronegative than copper. So in this compound, copper is losing total 3 electrons. 1, 2, 3. So its oxidation state will change from here oxidation state was +1, partial +3, or you can say +3 oxidation state. Be careful. Here I am writing +1 oxidation state. Actually, it is not completely +1. It's a partial +1 because electron is partially shifted toward carbon. But when I will say oxidation state, so it must be written completely like +1 it is. We will call it +1 oxidation state. Similarly here, it is partial +3 oxidation state, and we can call it +3 oxidation state. Now again, the oxidation state of copper is changing from +1 to +3. +1 to +3. Increase in oxidation state means oxidation is happening again. And because copper is added between carbon and X, again this step is oxidative addition. Like first one. So first and third steps are similar. Fourth step, the last step. In +3 oxidation state, copper is highly unstable. It is very difficult for copper to lose total 3 electrons. We know copper can lose 1 electron, so oxidation state can be +1. Copper can lose 2 electrons, oxidation state can be +2. +1, +2 valencies are common there for copper, but we have never found +3 oxidation state because it is very difficult for copper to lose 3 electrons. So in this condition, what it will do? It will make itself stable. How? By breaking bond from carbon and getting 2 electrons back. So when it will break bond from carbons, so here free radicals will generate. These benzene rings will become free radical, phenyl free radical, and obviously unpair electron of free radicals will combine and they will create a bond between each other. Diphenyl. The product will be diphenyl. And what about copper? The oxidation state of copper was +3 because these electrons were toward carbon due to higher electronegativity of carbon. But as copper got these 2 electrons toward itself, so firstly it will become CuX, and the oxidation state which was +3 will turns to +1 now because 2 electron it got. So obviously if 2 electrons it is getting, so its oxidation state will change from +3 to +2. +3 to +2. Sorry, +1. Decrease in oxidation state means reduction. And we will call this reduction reductive elimination. The last step is reductive elimination. Why we are calling it reductive? It is clear because oxidation state is changing from +3 to +1. That's why reduction is there. Why we are calling it elimination? Because you can watch this group is eliminated between from the center of two benzene rings. It is getting eliminated. That's why this step is known as reductive elimination. And finally, we are getting diphenyl as a main product. In this fashion, Ullmann reaction is happening. This was the end of the mechanism of Ullmann reaction. Now CUX that you got, it's a second CUX. First CUX we got in previous steps, and the second CUX we will get in last step. Now one more question. I told you X we can use iodobenzene, bromo, and chloro. Which is most reactive in Ullmann reaction? Very easy, it will be most reactive. Because between carbon and iodine, bond length is bigger because iodine atomic size is bigger. So strong, these lengthy bonds are weak bonds. That's why they can break easily and copper can easily insert between them and mechanism will be in progress. But when we talk about bromine and chlorine, bond lengths are decreasing because atomic sizes are decreasing. So short bonds will be strong bonds. These are strong bonds. That's why their breakage is very difficult during Ullmann reaction. That's why if we have to perform Ullmann reaction, we need very high amount of temperature, high temperature for these cases. And with fluorobenzene, it is completely impossible because the very short bond is there between fluorine and carbon, so it is a very strong bond. That's why Ullmann reaction is not shown by fluorobenzene. These three will show Ullmann reaction, and out of these three, iodobenzene will show very fast, or you can say it is very highly reactive in Ullmann reaction due to weak bond between carbon and iodine. This is the end of the video. Thank you very much.